Hi, my name is Jessica Johnson, and I would like to teach you some math that we learned in Chapter 1, Thinking Critically. I'm just going to share my screen right now. The first question talks about using 8, 10, 11, 12, and 13 to use these numbers to come up with a sum of 31 vertically and across. Usually I start with the middle number in the list, which is 11 for us, and I plug it into the middle circle. It didn't work out in this case. 31 minus 11 minus 8 equals 12, but 10 plus 11 plus 13 does not equal 31. So I did 8 in the middle, 10 on top, 13 on the bottom, across, down, and I did 11 plus 8 plus 12 equals 31, and 10 plus 8 plus 13 equals 31. And I used a whole bunch of different combinations while I'm using guess and check. And there was no other possible combinations where you will get 31 going across or vertically. The next set of problems was some of my favorite. It's where these outside circles will always equal in sum to what's in the middle, in between, sandwiched between these circles. So 7 plus 8 is going to equal 15. 8 plus 12 equals 20. 5 plus 12 equals 17. And 5 plus 7 equals 12. And the same for these. 7 plus 6 equals 13. 6 plus 15 equals 21. 15 plus 4 equals 19. And 4 plus 7 equals 11. And how I did to solve these problems is I took 15 minus 7 equals 8. 17 minus 5 equals 12. And 12 minus 7 equals 5. So I took what I knew, which was 15 minus 7, and plugged in my numbers, and I built up from there. But if you notice, there's no solution for 1b3 because 6 plus 3 equals 9, not 8. So this pattern does not hold. 1b4, 1 plus 6 equals 7, 6 plus 10 equals 16, and 8 plus 10 equals 18, and 1 plus 8 equals 9. So this pattern holds. And problem number 2 is asking for parameters. The possible parameters that I came up with was 12, 14, 16, 18, and 20. And the thing about parameters is going to be on the outside. So from here to here is 1. And from here all the way down to here is 1, 2, 3, 4, 5, 6. So I'm going to take and I'm going to count my edges. And I'm going to add them together, and this box right here comes to 18. And my smallest box came by a 3 by 3 box. And then my largest is a 1 by 9. But if I mentally moved these blocks around and just pictured different images, and if you notice that there's different ways you can get 20 for a parameter. And then number 3 talks about how to get from point A to point B. How many ways? But here's the thing. You can only move up and over. And I started drawing them out, but let me tell you, there is a way cooler way to figure out this problem, and that is using Pascal's triangle. Because Pascal's triangle, from 1 to 1, there's only one way to get there. And from 1 to 2, there's 2 ways to get there. Or 1 plus 1 equals 2, and 1 plus 2 equals 3, and 3 plus 3 equals 6. And it makes this really cool triangle. So how many ways can we get from A to B? Well, what I did is I took my graph and I just converted it. I tilted it, and I made where A was at the top, and then A equals 1 on the triangle. Then I used Pascal's triangle to help me figure out how many ways there are from A to B. So I've already went over 1 plus 1 equals 2. So 4 plus 6 equals 10, and 6 plus 4 equals 10, and 10 plus 10 equals 20. So there's 20 possible ways to get to Pascal's triangle. The next question is talking about this. It looks like a deflated ball. How many ways can you get from C to E? And with this, you have to pay attention to the arrows, because you can go from C to A, but you can't go from A to E because the arrow is pointing back. And there was 4 different paths that I found. I found from C to A to B to E. And then I found from C to B to E, and then I found C to F to B to E, then I found C to F to E. You can't go from C to F to D because the arrow is pointing back, to D here. And then our next question talks about the additional pyramid, which I think these are way cool because you're using a variable to solve your problems. And the neat thing about these pyramids, everything immediately above the number is the sum. So let me go back up here to 4a. So for us, we have 25 is given to us, x, 7, and 3. You should always start with what you know. And so I know to get this middle box is going to be 7 plus 3. 7 plus 3 equals 10. So I'm going to fill that in. And then to get x plus 7, I'm going to take x plus 7 plus 10 equals 25. And our 25 came from the top of the pyramid. And I'm going to take and I'm going to add 7 plus 10. X plus 17 equals 25. And now I'm going to divide by 17. X equals 8. And I'm just going to build my pyramid off the facts that I learned. So the facts that we learned is 25, 15, 10, 8, 7, and 3. And then I go back and check my answers. 8 plus 7 equals 15. 7 plus 3 equals 10. 10 plus 15 equals 25. Our pyramid works out. Isn't that awesome? And then 4b, same thing. You're just using variables to figure out your pyramid. And everything immediately above the number should be your answer in a sum. So to check our answer, 6 plus 2 equals 8. 1 plus 6 equals 7. 7 plus 8 equals 15. Same for 4c. It's a little different because the middle M is missing. So you're missing 2 boxes, but it's very doable. 8 plus 9 equals 17. 8 plus 2 equals 10. 10 plus 17 equals 27. And for this, you're just using what you know. Like we already know that Floyd and Josie are brothers, so Floyd and Josie are not going to be married. So they're going to get X's all the way down this row, and Sarah and Kitty and Annie are going to get X's because. And then let's talk about Josie and Gus dated some, but then Gus met his present wife. So we know Josie and Gus didn't get married either, so they're going to get an X here. And then Kitty is married to Will, so Will and Kitty's going to get a 0 here, and Kitty is going to get an X for David, Floyd, and Gus because they just can't all be married. And then Will is going to get X's for Sarah, Josie, and Annie. So you're taking what information you have and plugging it into a chart to help come up with a solution. Which Katie is married to Will, Sarah is married to Floyd, Josie is married to David, Annie is married to Gus. And then we're going to talk about trapezoidal numbers. So we are asked to create a dot pattern. So 1 plus 1 plus 1 will be 3 dots. And what you're trying to do is you're trying to build like a pyramid. And then 1 plus 2 plus 2 plus 1 equals 8. And 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 is going to be 15 dots. And then if you notice that 1 plus 1 plus 1 equals 1 times 3. And I wanted to show you this on the whiteboard really quick if I can. If you take 1 plus 2 plus 2 plus 2 plus 1 equals 8, but it can be rewritten. It can be rewritten as 2 times 4 because 1 plus 1 equals 2, so that's a 2. So you have 1, 2, 3, 4 2's all together. 2 times 4. Isn't that so cool? And then you have, for part B, 1 times 3, you're going to have 3 dots. And you're building columns and rows, basically. And then you have, and columns go up and down and rows go across. So 2 times 4 is you're going to have 4 columns and 2 rows. And 3 times 5, you're going to have 5 columns and 3 rows. And then the general formula for the trapezoidal number is n times n plus 2. And I am done with my presentation, and I hope you enjoyed learning math. Thank you.